The multiverse is a theory, or maybe it's more like an assumption. Okay, it's really a hypothesis, which we call an assumption. It's a synonym of an assumption. And what is the assumption? The assumption is that there is more than one universe out there. Okay, why is that significant in the case of physics? Well, because you have to define the key words there. Okay, you have to define what is the word universe, what is an object, which we more or less just covered. You need to have objects in physics, and you need to define also the key word I think in there, which is the word space. Okay, we need to know what space is. What is this thingy called space? Okay, that's essentially going to be the issue today. Okay, so we start with a fellow who made a comment today. And so I'm going to put his comment up there, okay? Here, I'm sorry, I'm going to start with philosophy here first. We have to distinguish philosophy from physics, okay? And why is this philosophy, this part? Well, because philosophy deals primarily with concepts. And the problem that we have with concepts is that, people have no idea what a concept is. They have this vague notion from ordinary speech, and they introduce it into physical interpretations, into physics, okay? And the main concept, again, is this thing called space, which is a synonym of nothing. Space is nothing. They're both the same word, okay? You don't have to use the word space. You can use the word nothing. But what is nothing? Well, for that, you need to know what something is, an object, a thing. And so, you have to define something, and then you have to define nothing. And hopefully they are antonyms, okay? So they're opposites, okay? So that you can use them consistently also. Okay, and so because we're going to be dealing with the multi-universe, and the question is, what separates one universe from another? That's going to be the key issue. Okay, so I start with philosophy here. One fellow put a comment there, says philosophy should use at least two basic axioms. He says it's a way of thinking. Okay, that's what he thinks philosophy is. The problem there again is, how many ways of thinking do we have on Earth? Like 8 billion? Everybody's a philosopher if that's the definition. Okay? If philosophy is a way of thinking, then everybody has a way of thinking, and we have 8 billion philosophers on Earth. And so the question there is, what's the difference between Aristotle and Plato and the rest of humanity? We call them, he's a Greek philosopher. So what was different from him? He had a way of thinking. What's the difference? We're all philosophers then. So it has no meaning if you just say that it's a way of thinking. That's not a definition we can use in any way, shape, or form. And then to make it worse, he says philosophy should use at least two basic axioms: the law of identity and the law of self-contradiction. And you look them up and they say, law of identity, each thing is identical with itself. A is equal to A. How much idiocy can a person say that A is equal to A? And so let's go to the law of self-contradiction, or it's the law of contradiction. He said it as self-contradiction, but I looked it up. There's no such thing as law of self-contradiction. But same thing. The point is that there's an example more than a definition. A cannot be both B and not B at the same time. So law of identity, A equal A, and law of self-contradiction, A not equal B. Great. That's it. It's this kind of idiocy that is out there. What is idiotic? It comes from big ideas. It's not a little idea. It's idiot. Okay, so we call them idiots. Okay, so anyone who has this kind of nonsense, this garbage that has no place in science, no place in anything, this is for a loony asylum. What is this? What do we do with this? This is garbage. Another fellow says philosophy is the search for truth. What is truth? Well, truth is a belief. It's an opinion. What is true to you is a lie to me. And I'll prove that truth to you. Okay, very simple. Give me any fact, any truth, anything that you want, anything at all. Anything at all. You might say, does God exist? I say no. Okay, or you say yes, I say no, or I say yes and you say no. No matter what you say, I'll say the opposite. Okay, I won't agree with you. So you say, okay, how about pi? The number pi, that's a fact. And I say, no, it ain't. And you say, no, let me prove it to you. And you do all these examples, tests, experiments, whatever you want. And I say, no. I don't believe you. I don't accept it. So what is true to you will always be false to me, because I just want to play devil's advocate. No matter what. No matter what you say, I don't care. I'll take the opposite point of view. So what do you do? Okay, so this is the issue. The issue is truth is an opinion. Always. Okay? There's no such thing as fact, no such thing as truth. All those are opinions and nothing but. Okay, so let's keep that in mind. And here we go with this. This is the scientific version of philosophy. Okay, and science is what? Rational explanations. Very simple, very straightforward. Physics, rational explanations of mechanisms, right? Causes and mechanisms. And philosophy, rational explanations of behaviors, okay? Reasons and purposes. That's essentially the difference. Now we have a definition that you can say, okay, now we know what philosophy is for the first time. Because if you have all these notions of that philosophy is just a way of thinking, which is the notion that most people have out there, then you don't have a definition that is worth anything. Okay? Love of knowledge, is that what the Greeks called it, or is that how it was translated? What is that? What is love of knowledge? That's nothing. Some people say that philosophy is not even a branch of science. Others say that it's the mother of science, that you need to have philosophized before you can do science, and so on. They have all these versions. So no one has any idea what philosophy is. Everybody just goes back typically to Aristotle, who did a pretty good job of defining it in the Greek manner, or synthesizing what the Greeks thought of philosophy. And so they say, yeah, philosophy is a way of thinking. That's essentially what people have in their minds. So it's his philosophy. So we all have a philosophy. We all have a way of thinking. We haven't learned anything by saying philosophy. The only way you can make sense of it if you chop it off and put a very strict specification, okay, very strict criteria, and say, look, it's the explanation of behavior. So you could put in there history, you can put in there psychology, you can put there almost anything, anthropology, why someone does something, okay, why that person behaves the way he or she behaves. Then you can use it consistently. Then you can say that's philosophy. And that's distinguished from physics, which is an explanation of mechanisms, physical interpretations. Okay? So now we have a distinction. Now we can use the word philosophy correctly, you can use the word physics correctly, and they both fall under science, which is rational explanations broadly in general. Okay, why do we start with philosophy today? Because we have this issue of the concept. People have no idea what a concept is, and here you see it. One fellow says, object, that which has shape. Yeah, okay, we see eye to eye on that one, but then he says concept, the change in shape of an object. The change in shape of an object. What sense does that make? Are there static concepts like distance? What's change in the shape of distance? But distance is easy. Let me give you a hard one. I'll give everybody a hard one for you to think and break your head this week, okay? You want to do homework? Do homework on this, okay? Here it goes. Here we have articles, pronouns, and conjunctions. Are those concepts or physical objects? Well, hopefully they're concepts, okay? We usually refer to words such as these as concepts. Okay, so you have a very simple concept, the, or a, and these articles there, right? That. How about pronouns? You have what, him, they, that. Okay? Conjunctions, and, or, but, that. I put one common denominator, that, which is the word that. Because you can use it as an article, a pronoun, or a conjunction, you see on the right there. Okay, so what change in shape happened there, according to this fellow? The word a, for example, the article, or the word that. Where's the change in shape? Okay, but see, in all these cases, what you see, and there are examples there on the right, you're implying something else. There's a comparison, there's a relation with something else. That spoon, meaning you're referring to that one with respect to something else. So the word that already embodies, it's a concept because it embodies two objects. One is tacitly understood because you're referring to that spoon and not the other one, or that, or some other spoon or utensil. Okay, that is the situation, which is different than the other situation. He took the books that were sold, not any book, but those specific ones. Okay, so all these words show that you are comparing against something. Okay, so that's why the word concept, what is a concept? Concept is a comparison between, it's a relation between two objects. One object is implied, tacitly included, invoked in some way in the word that you call a concept. There's always two objects involved in every concept, no matter how you look at it. Certainly distance, certainly direction. How can you have direction without two, for example, okay? But, you know, if you want to break your head to see, test my definition, I mean, test it, I don't care. Come up with whatever you have, okay? Bring it on. And tell me why a concept is not a word that involves or invokes in some way or other, implies, it tacitly includes two objects, okay? Which means that you need to define the word object before you can define the word concept, because the concept is two objects, okay? Or involves two objects. Okay, so someone here tried to define it as well, said concept. An abstract idea. Okay, what's abstract? existing as an idea. And what is the idea? A thought produced by thinking. No, you cannot use the word idea or the word abstract to define concept, because essentially they're all synonyms. So no, these people go out there and they look for definitions that they find, and they just copy paste without analyzing. That's where the problem is. Okay, and here's one fellow, and he says the following. He says, "Is the table a concept, a static concept?" Okay, and he says, why? Why does he have doubts? He says, "We reason with atoms." Uh-oh. We reason with atoms. He says, "The table is an aggregate of atoms." Oh man, he's got to run into trouble. Why? Because of this. Because it's mereology. And he doesn't understand what mereology is, I guess. Mereology is what something is made of. Okay? They have several versions, or a couple versions at least. One is time slices, and another one is what something is made of, meaning many atoms. So he's looking at the wrong thing, and that's called mereology. Okay, so this is where the problem is. He says, "Is the table a static concept? We reason with atoms. The table is an aggregate of atoms." No way. That's not what a table is. Okay, table is not a bunch of atoms. Neither is air a bunch of atoms. Neither is anything a bunch of atoms. Bunch of atoms, mereology. Okay, and that's known as religion. Okay, we don't use mereology in science. That's the ordinary speech, the notion of ordinary people out there who have very little brains to analyze these things. Okay. And then so he gets into trouble because he says, well, all these atoms are in continuous movement. Well, no kidding. Everything in the universe is in continuous movement, no matter what. Even if it stands still, if the Andromeda galaxy is moving with respect to us, everything here, every atom that you think is static is moving with respect to the Andromeda galaxy. So yes, everything in the universe is moving in this universal movie, as I call it. Okay, there, in every frame, you have a different location for every single atom in the universe. There's no way to avoid it. Motion is part of the universe. Okay, and so yeah, you cannot talk about continuous movement because that's irrelevant totally with the subject matter at hand. The subject matter at hand is, what is an object? Is it something static that has no motion? And so this guy gets tangled in his own language because he says it's made out of atoms, all atoms move, so therefore, since nothing is static, then what we have is no object, because the object is changing its shape, as this other fellow said, every second of the day. And so they get tangled in their own semantics. They go around in circles. So he says, in continuous interface with other aggregates of atoms, which can be the floor, static or dynamic concept or object. Again, he's thinking the floor is made out of atoms, all atoms move, therefore the floor is moving, therefore it's not static, etc., etc. And then he says, and the air that surrounds it, static or dynamic concept or object. Air is always static. Air is a static concept. I'm sorry, a static object. Okay? Why? Because you can take a cross section of time, okay, one frame of the universal movie, and in that frame, nothing moves. You have a cross section of time, a cross section of motion. It's known as location. Okay? When you have location, okay, what you have is that it's a static concept. Okay? And so yeah, here you have it. Here you have air, okay? And what is air? Well, air is a static blob. That's all you see there, okay? So this fellow says, is air an object or a concept? The air is constantly moving. All the atoms are moving. They're changing their location with respect to each other. He's looking at many frames of the universal movie. That's where the problem is. Let me get that out of there. And so you see the air inside a balloon, and you only have a few atoms there, okay, just to illustrate it. Does it bother you that there's a balloon there? I mean, you should imagine this with the balloon completely filled with air, okay? Does the balloon bother you? I mean, you say, well, it's the balloon holding all the air. Because if there were no balloon, the air would, what? Move. That's what people have in the back of their minds, okay? And so let's get rid of the balloon, okay? Here we get rid of the balloon, and we'll only have the air, okay? Just so to simplify things for people, okay? There we have it, just the air. We got rid of the balloon. And you have to imagine gazillions of atoms between those air molecules as well, okay? And so the question is, can we take a snapshot? I mean, hopefully we have colors. In this case, we're going to color them green or bluish there. We take a snapshot of that. Can you take a snapshot of colored air? Yeah, and the answer is yes. You color code the air, okay, and we'll call that air, okay? We take a snapshot of that. Now you have a photograph, okay? Now it's not moving, not inside the photograph, it's not. Do you have a shape there? And the answer is yes. And it's a standalone shape. We can take a blob of air, maybe even easier to imagine, a blob of water, as I say, take it into outer space in a balloon, pop the balloon, and suddenly this thing rushes out. You take your camera, or the astronaut takes his camera, takes a snapshot of that. Click. Now he looks at the at the picture. What will it show? It'll show a blob, a static blob. Does that static blob have shape? That's the $1,000,000 question. And if it does, well, then you have that thing that you're calling water, that thing that you're calling air, whatever you took a picture of. It's static and it's a physical object. Anything made out of atoms hopefully is a physical object. Okay? All you have to do, if you don't believe me, just go out there, get your camera, take a snapshot of water, and see what comes out. See if it's moving inside your picture, your static picture. If it ain't moving, well, it's not, and you see a shape there, then you have a thing. And people say, well, it takes the shape of the container. Who cares? It doesn't matter. I don't care what shape it takes. We're not talking about what is the shape of water, what is the shape of air, or of gas or anything. We're saying, does it have shape? And hopefully a bunch of atoms, mereology, okay? When you take a snapshot of that, hopefully that has shape and it's not moving. In a snapshot, hopefully it's not moving inside the picture, okay? Because if it does, maybe you drank too much. Okay, so that's the issue. Okay, so here we go back to concept. Okay, we need to settle this thing about concept because people are having big trouble understanding what a concept is and distinguishing them from objects. Okay, so a fellow says, you said, what is a concept? Yeah, correct. And I asked that question, I answered 2 objects. Well, he put that shorter version, okay, 2 objects. And he says, no, maybe a relationship between 2 objects. The problem is you cannot define it using the word relationship because relationship is a synonym of concept. So you can't use the word relationship to define the word concept because you're saying the same thing, okay? So we say concept. Let's get it right, okay? Concept. A word that invokes or embodies 2 objects or implies 2 objects or, tacitly includes or whatever, however you want to see it. We need 2 objects to define the word object because the word concept because every concept already contains within that concept, it implies in some way that there are 2 objects. It's a relation between 2 objects. That's what a concept is. Nobody ever figured that out. Okay, so because they never figured it out, they never were able to tell us the difference between an object and a concept, and a lot of people still to this day have problems distinguishing between concepts and objects. Some people think that energy is an object. Some people think that love is an object. And when you ask them, well, is God a concept or an object? And that's when they run into a lot of trouble. They don't know if they're praying to a concept or to an object, to a thing. I mean, is God a thing, like a man or whatever, or is God a love, intelligence, energy? What is love? What is God? Okay, so here we have fellow says, the relationships have shape. Do relationships have shape? And he answers, right? Yes. Okay, that is why relational databases. That is why relational databases and non-relational databases have different architectures. See, this fellow, the fact that you use a computer and you do programming, for example, and they program these objects, as they call them, and they move these objects around. Well, some of them are objects, but not all of them. Those which have shape are objects. But, relationships are comparisons between 2 objects. The relationship itself is a concept. And he says, well, there are relationships that have architecture. Yeah, please draw a relationship for me. I want to see a relationship. Well, I want to see the architecture of a relationship. Okay? And this is where the problem is. These people think that, because in the computer world, we can do a lot of these abstractions and give them names such as objects or call them architectures or whatever. He thinks you're dealing with objects, with things. Not so in physics. Physics is something different. Physics, you need real objects. Objects which, meaning that which has shape. That's what you're talking about. And relationships, please draw it for me, okay? I want to see a relation. Take a snapshot of a relationship. Okay, I don't know what you're referring to. Okay? And certainly not out of, out of the computer world, the programming world. You can't use any of that in physics. Okay? And again, it's because people have, in this day and age of services and so on, a lot of people do computer work, programming, database, data entry, etc. And they think they're dealing with things. They put a number in there that says, I put a thing in there, I put an object, I put an entity or whatever. No, a number is not an object. Okay? The object, you can say the number 5 has shape. Yeah, the number 5 has shape, meaning, that thing that you put in there, that has shape. But you can't say that's a 5 because the word 5 has some other meaning. So you can't say a 5 has shape. No, 5s don't have shape because 5 means something else. Okay? That thing that you had put there with that little curlicue, that's not an object. Well, that is an object, but that's not a 5. Okay, that's an S or whatever you want to call it. But that thing there is not a 5. 5 means something else. Five is a concept. And so people confuse objects with concepts, okay? Paul says, object, a collection of matter. Again, you get into mereology, okay? Matter, what is matter? You look it up, many objects. That's what it is. That's what matter means. Many objects, existing objects, actually. And so, yeah, it's mereology, it's religion. That's what you're talking about, okay? Paul also tries to define other words in there, okay? Space, boundless 3D extent. Okay, you look up extent, it's a verb. That's what extent means. It means to extend. So there's no physical object called extent. Okay, so you can't say that extent is three-dimensional. Okay, there's no such thing as a three-dimensional extent because you're saying that there's a three-dimensional verb. It's like saying that running is three-dimensional. That's what he said there. And then no object is boundless. Okay, so space is not an object because if it's boundless, it's not an object. All objects are bounded, finite. Okay, that's what object is. It's a synonym of finite. And so if it's boundless, you're not talking about an object. What's the object doing? Growing? Why can't you see the outer shape of it? You know, the only way to tell me what space is if it's a thing, if it's a container, then you have to point to it. And for that, you got to show me not only the shape of space, but you got to show me what's providing the background to space that gives it shape, that there's a contrast. So unless you can do that, space is not an object. Okay? And much less if it's the extent, something extending, I guess, boundless extension. For sure, that's just a verb. Okay? You're saying that a balloon is growing. That's all you said. And you can't see the outside of a balloon. You can't tell me if the balloon is cubic, it's roundish, triangular. You can't tell me what the shape of space is. What is motion? He says it's change. You look up change, it's motion. Great. What is time? It's an interval. What's interval? It's a time. What does exist? Reality. What's reality? Exist. So this fellow just copied and pasted a bunch of synonyms, which is what they have in ordinary speech and in mathematics, and he put them on here online thinking that he did a great job. You know, he put no brain power into this at all. All he did was copy paste and say, this is what it is. This is what's through tradition. This is what we all think it is. Democracy. Everybody voted for this. It's worthless. Worthless nonsense. Not useful at all. Okay, so this is, you could say, the synthesis of that. Questions that we need to answer today. Keep these in mind when we go into this multiverse, because we're going to try to find out really what space is. This is what the issue with the multiverse is. What is space? Is it a thing? Okay. Is it a concept? Okay. If a thing, is it finite or infinite? Like this guy says, boundless extent. No such monster as extent, but if it's boundless, for sure it's not an object, because all objects are bound, okay, finite. Is space a container? I mean, let's say they put you in a container, such as a jail, a prison. Can you get out? Well, yeah, maybe you drill a hole through the wall and you get out of prison. Is that what space is? A container that you can get out of because there's something on the other side of it, providing contrast? Background. Is that what space is? And then the question is, if it's a thing, did God, Big Bang, whatever, create this thingy called space? Where was he standing? Where was God standing? Outside of space? Created space out there in front of him or whatever? Is God outside of space? Can there be anything outside of space because space is finite? Or is space boundless, meaning nothing is outside of it because nothing is space itself? Okay, so the issue here is we need to answer what space is. Why? Because we're going to try to figure out what separates one universe from another, which is the notion we have of the multiverse. Okay, that's going to be the issue. Okay, so let's get into the subject matter today, and that's the multiverse. Here we go. Okay, and a fellow starts out by putting a comment. He put it, I think, today. Okay, and he says the following. He says, let's start with universe. Okay, this comes from universes. Okay, we don't care about the etymology. Okay. But he says it means turned into one. Okay, so universe means one, essentially, uni, okay? And multiverse means more than one, turned into many. Okay, essentially that's his reasoning. Okay, so far so good. So we're saying universe is one, multiverse means many, okay, many universes. I know you are going to say that universe equals one thread, and there you see the threads that I'm saying that all matter is made of, okay? Many verses or many universes equal many threads, okay? And I put two there, so we can say that maybe you have one set of objects that are made from one thread, and you have the other set of objects unconnected to our universe, our bunch of matter, made of a different thread, okay, and it's twirling somewhere else, okay? But what's the issue here? The important issue here is what the black stuff is. Because when we use the word universe, we're saying that it's matter and space. Okay, so we have matter and space. But here, these two universes, okay, these two threads, they share the same universe, the same space, the same space. Okay, so are these two different universes, or are they like the galaxies that are just far apart, but the galaxies are connected? In this case, these two universes, these two chunks of matter, we could say, are not connected. Okay, but so they're twirling around and you have all this matter made of these threads, right? But they're just not connected. But even if they're not connected, they share the same space. That's the issue. And if universe includes the word space, then these are not two universes, no matter how you look at it. If the word universe includes, right, the word space, if it has to include that word, then we do not have more than one universe. There is no such monster as a multi-universe. There can only be two chunks of matter, two threads, you can say, for example, in this case, to talk intelligently. And within each one of these threads, you have galaxies, which are very far apart, but they're all physically interconnected. Okay? So he says, but what about superimposing many threads in space? So he's saying that what happens when all these threads, you have these two threads, and let's assume they superimposed, okay? And the question here is that, or the issue here is that, this is an irrelevant matter because we're trying to find out the multiverse. And he's saying, well, what if they, all these threads get tangled or they mix with each other, go through each other, whatever? What about that? Well, it's got nothing to do with the word multiverse. And the issue here is the following, that I'll answer with a question or a couple of questions. Did you ask that question in the context of particles? I mean, people say, oh, Bill, so many threads. Well, how about so many particles? And all these threads, they go through each other, and all the particles go through each other. They occupy the same space, so to speak, same time. So the question you should ask yourself is, don't ask what your country can do for you. Ask what you can do for your country. Don't ask me about the thread. Ask the question to the guy who proposes particles. I mean, if you have another proposal, you say, well, I don't believe in particles. I don't believe in threads. I don't believe in waves. What do you believe in? What's your proposal? What's your assumption? And whatever assumption you have, I'm going to ask you the same question. How many are there of these thingies that you're proposing? Do they go through each other? Can they occupy the same space? So no matter how you twist and turn it, we're going to have the same questions. I don't care if you talk about particles, waves, threads, you're going to have the same questions. Are there so many? Yes or no? And how do they go through each other? Do they go through each other? If not, explain how this universe works. So this is the issue. Okay, so by saying or by raising the issue of how many and how things go through each other, you got the same question with particles, with threads, with strings and string theory, which are just particles. String theory is a particle theory. Okay, talks about locations, and as always, locations are filled with nothing. So, yeah, you got the same questions no matter what proposal you propose, what theory you have. Okay, so here we have couple fellows, and they discussed the multiverse, and so we're just going to take with them, okay? Because one guy proposes the multiverse, he calls himself a physicist, and the other guy proposes that there is no such thing as a multiverse, and he calls himself a physicist. Turns out neither one are physicists, they're just mathematicians, okay? And they don't even follow the scientific method, they follow the mathematical method, and that's why they run around in circles, and people think that these people are geniuses because they do a lot of math. But it turns out that all the explanations they give and all the arguments they propose are totally irrational. So let's go with the first one. The fellow's name is Siegel, okay, Ethan Siegel. And the guy's going to challenge him is Adam Frank. Okay, and so first guy, Siegel there, says, is the multiverse real? And he's going to say yes, and the other guy's going to say no. And so they say two astro-mathematicians debate. And then you see two notions of the multiverse. You see all these balloons there, or balls. In both cases, the one on top, the other one on the bottom, on the left, right there. And this is the notion they have. And the only thing I want you to focus on, especially on the one on the bottom, which is a little clearer, is I need to know what that black stuff is that separates all these balls, all these balloons. So I want you to concentrate on the black stuff. That's going to be the key issue today. Okay, so let's move along here. Okay, Siegel, the first guy, he goes and he does this. He says, this is how he justifies the multiverse. He says, in the beginning, there was energy. Whoa, there was energy. What is energy and how did it get there? That's what he's got to explain. But he doesn't. He just goes in there. He says, in the beginning, there was energy. Okay, so he just starts out with something, whatever this energy thingy is. Okay, and he says, energy causes the universe to expand. Well, what is the universe? I mean, how does energy cause the universe to expand if the universe includes this energy? And what gives shape to the energy if the energy causes the universe to expand, meaning there's this balloon, energy is inflating somehow? Is that what the universe is? A balloon or a ball of some kind that energy pushes it outwards? This is the notion these people have. This is what they ended up with in the 21st century. Okay, so he says the universe fills with matter and radiation. Okay, in other words, this energy converts into particles. Okay, this is his reasoning. How a concept called energy turns into a solid thing called particle, we don't know, no mechanism, and you don't have to worry about that anyways, because it turns out the particle is not a particle as he suggests it is. No, the particles are equations, wave function collapses. That's what these particles are, so-called particles. They're not corpuscles like Newton would have thought of them. Okay, so we're not talking about a little ball, a little dust, grain of sand, or a piece of dust. We're talking about just equations. So the energy, which is an equation, turns into another equation. That's all you said so far. Okay, but he says, imagine ripples generated by a ball dropped into a pond. Okay, there we see the image on the right. Imagine that. Okay, if the ball rolls faster than the ripples propagate, then inflation ends, and we have a single universe. All we have is one universe. Okay, great. If the ripples propagate faster than the ball rolls, then we have the multiverse. Okay, this is his reasoning. This is, if you can call it reasoning, right? Okay, and by the way, this fellow, he's trying to become popular. He wants to hit it big not in the physics world. He wants to hit it big in the celebrity world. He wants to be like all these other, Brian Greene and DeGrasse and all these other people. He wants to make money. So he's not a physicist. He's just a guy who uses mathematics to see if he can get to be a celebrity. That's his whole entire goal. So he dresses up in a fancy way so that people notice him. Like Bill Nye, the mathematician guy. They all just want to be celebrities. That's it. They don't deal with physics at all. And so they give these common physical interpretations that people are used to: Big Bang, black hole, dark matter, and so on, particle at two places at once. And with that, they want to see if they can, hit the big time. That's all they're doing. Okay, so here's the other fellow. This is Adam Frank, and he says there is no empirical scientific evidence for the multiverse. So his criticism is not that what Siegel said is irrational. He's saying we have no evidence. So he thinks the prosecutor has to show the jury, the multiverse in some shape or form. That he says, look, here's the universe. Now we have proof. We have evidence. That's his notion. That's what he criticized. And he says, in scientific theories, the multiverse appears as a bug rather than as a feature. We should squash it. So his notion is not that it's irrational. He says it's just we have no way of proving it. So what kind of theory is that? Where he says, or assumption is that you cannot verify in any way. That's his rebuttal. That's his complaint. Okay, so neither one, as far as I'm concerned, did any good job on this, but they're considered big celebrities. They got these big names because they want to hit the big time. They're not into physics. They're into mathematics, and worse than that, they're into being celebrities. That's all they care about. Okay, and so this is the rundown. Okay, this is going to be my reasoning. Okay, Siegel and Frank, they're just mathematicians. They're not physicists, astrophysicists, or any of that. Okay, a physicist is a guy who can explain a mechanism. He's got to explain gravity. That's what he's got to do. That's what Siegel and Frank have to do if that's what they do. If they're astrophysicists. Okay, you specialize in physics related to astronomy, right? Then that's what you got to explain. You got to explain stuff like, why does the Earth go around the sun and does not spontaneously exit the solar system? That's what you got to explain. And to say that you're a astronomer, meaning a physicist, and you cannot explain that, which is very simple. You cannot physically give me a physical interpretation of why the Earth doesn't fly out of the solar system or out of the universe, for that matter. Then what kind of astrophysicist are you? What do you do? What do you do for a living? Just equations? Okay, and so if they're mathematicians, okay, the majority of mathematicians, I would say over 50%, believe in the multiverse. Maybe I'm wrong. Okay, that's my impression. I would say close to 50 or maybe more than 50% believe in the multiverse, that there are more than one universe out there. So what do they mean by that? Well, what is a multiverse? Multiple universes, as we just said. Okay, right? What is a universe according to mathematics? Well, according to them, it's space, time, matter, and energy. All those put together, that's what makes up the so-called universe in mathematics. This is their notion of universe, okay? And so you look it up, and I think this comes from the Wikipedia, all of space and time and all other forms of matter and energy. That's where it comes from. So I think you can look it up at the Wikipedia. You'll find those specific 4 words. Space, time, matter, and energy. That comprises what they call universe. The important word there is the word space. Okay, I want you to focus on the word space. And you'll see why. Because we need to know what separates one universe from another in the so-called multiverse. Hopefully it ain't space, because space is part of universe. Okay, we got the idea here? So what separates universe 1 from universe 2? Well, the mathematical answer is space. But I thought you said space is part of the word universe. So if you said universe is equal to space, time, matter, and energy, meaning space, right? And now you're going to say what separates universe 1 from universe 2, and you say space again, well, you got a problem, because what is this a different kind of space? Has a different flavor, a different smell? What's different about this space that separates the 2 universes that include space? That's the question. Okay, and so what was space? Well, the boundless 3D extent. That's the definition that this fellow earlier said, and that comes from the Wikipedia. Again, these people just copy-paste that you'll find in the Wikipedia. So space is the boundless, meaning infinite, right? 3D, right? What? Verb. Great. Great definition. Okay, it's the extended extent. Okay, great. And in physics, extent is a verb, to extend. And in mathematics, space ends up being a 3D verb. So that's what we learned from mathematics. Okay, so I want you to follow through, understand what the argument against that, the rebuttal is. Okay, so here we have Mr. Siegel, okay, and this is the way they draw it in his article. I guess he approved it, okay, so he had an artist draw it. I want you to focus on what separates these universes, because that's the key issue. What separates the universes? And this is what he shows. It shows these black universes with some streaks there. He's showing the expansion of the Big Bang expansion in each one of these. And what are all these universes separated by? Well, they're separated by some green stuff, some halo there, some smoke or whatever. And that's the key issue. The key issue is, what's that green stuff? Forget about the universes. I want to know what the green stuff is. I want you to identify the green stuff. And he says here, or this is the caption there, it says, regions where inflation ends, shown as the baby universes here, are always what? Separated by what? A much more rapidly expanding sea of what? Inflating space. So what are these universes separate, which contain space, that black stuff inside them? What are they separated by? They're separated by more space. So it looks to me that maybe what we should do is just do it the correct way, and let's get rid of the green stuff, because that's space. Here it is. This is what they should have shown. Okay, this is the way you should draw that. In which case, and again, those arrows indicate motion. Okay, but all you have here is matter separated from matter by what? Well, there's distance between them, and that distance we call space. That black stuff there. That's the way it should be drawn. Okay, so why don't they illustrate it like that? Because if you illustrate it like that, then you don't have multi-universes, because you cannot have multi-universes. Okay, all you can say is that they're chunks of matter. And the only issue there is whether those chunks of matter are physically connected, like in the theory of, in thread theory in the rope model, or whether they're not connected if you assume particles, for example. If you assume that all these are just particles, okay, made out of atoms within each one of those, and there's just big distance between one lump of particles, like galaxies, for example, that are separated from other galaxies, well, those are universes. That's all it is. What are galaxies? Just island universes, you can say. And the only issue there is whether they're connected or not. Are they physically connected? Well, hopefully if the Andromeda galaxy is coming towards us and ours towards them, and we pull on them and they pull on us, hopefully that's done through some kind of physical mediator that extends from there to here, from here to there. Otherwise, why are we pulling on Andromeda? Why is it coming towards us? Why is it drifting towards the Milky Way? Why doesn't the Earth fly away? Why does it roll around the sun continuously? What keeps it bound to the sun? Magic? Are we going to say mass? Is it gravity? Is that what it is? These concepts? No, hopefully it's a physical object that prevents the Earth from flying away. Okay, and why doesn't the Earth slow down and fall towards the sun? Well, maybe, just maybe, it's because space is nothing, and so the Earth has nothing to rub its shoulder or its elbow against when it goes around the sun. That's why it doesn't slow down, because there's nothing, literally, to slow it down. Meaning there's only space, and space is nothing. So now we have a rational explanation why the earth doesn't slow down. But to say that mass pulls on the earth and the earth doesn't fly up because of gravity, all you're putting is concepts there. You don't have a physical interpretation. You cannot tell me the cause. Okay, Siegel here, again, this is a different version. And again, he's got all these universes out there. He's got some blue, I don't know, medium there. Looks like these balls are on a table, and then there's some green, bluish green medium there that separates them. It turns out that blue medium is space, and what's inside of each one of these globes is also space. Perhaps Siegel should have done it like this. Maybe that's the way they should have drawn it, so that you are not confused into thinking that one chunk of matter, one blob of matter, okay, is isolated from another blob of matter because they all have the same shape, the same space. They share the same space. Okay, so the issue here is, what's the blue stuff? That's what you got to, or in this case, right? What's that bluish stuff that keeps these universes apart? Because if space is what's going to be between the particles or the things that form one ball there, what's outside of it? More space. And if there's more space, there is no difference between one universe and the other. You cannot talk about universes. It's a single universe because it's one space, whatever space is. And if you say that space is a thing, well, you got a problem, because now you got to tell me what's outside of space, giving it contour, meaning it turns it into a container. And if it's a container, it means it's got walls and something's outside of those walls. You can escape through that container to some other place, maybe to meet God or whoever who made that container. So this is the issue. The issue has to do with space. And I like really Salvador Dali's version of this, and here it is. That's more or less what these people are doing, something surrealistic. Okay, they're saying that all these universes are separated, from each other. And what you got to identify is that bluish, greenish stuff that separates all these balls. That's the key issue. Because if each one of those balls contains space, then there's no difference between that space, which is colored differently, from the space that separates each ball. That's the key issue. Okay, so here's the notion that they have to dispel. Okay, let me illustrate for last time. Here it is. Okay, what you got to identify is the black stuff. Okay, if each one of these universes, expanding universes, since the Big Bang, is a separate universe, separated from the other universe, us and them, so to speak, right? We need to identify the black stuff. And if the black stuff is what separates each one of those galaxies and stars and planets that's in each one of those universes, then there is no difference between these two so-called universes. There is no us and them, because us and them share the same space, which is where all this matter is trapped in, and it's trapped forever, because if space is nothing, meaning it has no shape, then none of this matter can escape this so-called space, this nothingness. How do you escape nothingness if it doesn't have a border? Because the definition of space is that which has no shape. Okay, so not even God, if God exists, right? If you want to postulate God, no problem. But if you postulate God, God cannot, and you postulate God is a thing, God cannot leave space, because space has no boundaries. So where's God going to go? How can he escape that which has no boundaries? That which has no shape, that which has no borders, no fence, that which is not a container. So those who don't like my definition, that which has no shape for space, right? They don't like that definition. Hey, start by defining what space is, meaning what nothing is. A thing, that which has shape. Nothing, that which doesn't have shape. Now we can use these words consistently in a dissertation. If you're going to go out there and say, well, I don't like your definition, great, I don't care. Don't like my definition, don't vote for it. Give me your definition, defend it, and see if you can use it to explain, how the universe works.